is David and I'm part of the student group Star Dresden, and together with a few members we founded the group SCFi. We are working on carbon nanotubes. You can imagine carbon nanotubes, short CNTs, as atomic scale little straws which can be aligned after each other into structures like fibers or even meshes. Our goal is to align these carbon nanotubes within a suspension, and we'll apply an electrical field, a really strong electrical field, and under microgravity conditions we'll then observe the alignment process with dual vision cameras, and this should help us to analyze whether gravitational forces have an impact, and if they do, which impact do they have, and are there possible ways to enhance the alignment process even though there is a gravitational force. Our setup will contain 6 cameras and 4 high voltage chambers. They look like this, have 2 metal electrodes, and then they will apply an electrical field to the suspension which is in the chambers, then contain the carbon nanotubes. We have 6 cameras on top which are always in a group of 2 filming those alignment processes within the chambers, and we afterwards create then the 3D model. Nowadays more and more materials with fibers are used to build materials which are stronger, lighter and more durable. And with the carbon nanotubes, with their special properties which are like really good electrical and thermal conductivity and mechanical strength, you could build super materials. Imagine the Faraday cage, which is usually a really massive metal construction. With the carbon nanotubes you could make fibrous materials which then have a similar or even better protectiveness with regard to the electrostatic discharge, and therefore could be used in space applications or general applications where the weight is really critical to the design process. At SAM we are using the catapult to maximize the time window of microgravity for our experiment. And furthermore, SCFi will be launched with an altitude rocket during the REXOS program, and with the 9 seconds of microgravity here at SAM we'll get first impression and the first test environment for our next mission, which will be then 2 minutes of microgravity in the mesosphere.